To understand multiple inheritance, this is the program. Like here, I have defined a class student which has a parameterized constructor and a function. There is an independent class marks. Again, it has a parameterized constructor and a couple of functions. Now this result class is inheriting the student class as well as marks class. So how the object of the result class can access these parameterized constructor and functions of the student class and these parameterized constructor of the marks and these functions of the marks class? How can it be done, right? Can the derived class can access the attributes of the two base classes? So these questions will be doing it practically. Like for example, I am running it. So this output displays the attributes of the two base classes which are being inherited and the things which are computed in the derived class also. Your so many queries related to multiple inheritance will be solved in this lecture. So watch this video up till the end. As it is very clear from the name that multiple inheritance means a class will inherit more than one class. Like there are two classes A and B. A class has certain functions and attributes. There is an independent class B. There is no relation between these two classes. B class doesn't inherit the A class, right? Now when the C class will inherit these two classes, the object of C class can access the functions and attributes of A class as well as the functions and attributes of B class. And it is not essential that the C class can inherit only two classes. In multiple inheritance, a class can inherit any number of classes, right? But there is a problem called diamond problem in multiple inheritance. For example, this B class inherits A class. So the class B has a copy of all the functional attributes of class A. This class C also inherits A. So a copy of functions and attributes of class A are assigned to the class C also. Now this D class is doing multiple inheritance. It is inheriting both classes B and C. So now D has two copies of the functions and attributes of class A. Which of those two copies the object of D class will execute? But to understand diamond problem, we have to do one lecture which is known as method overriding. This is 18th lecture. In the 19th lecture, I will explain method overriding, and in the 20th lecture, I will explain you how Python resolves this diamond problem. That is a technique known as MRO. We will see to it later. Now, what is method overriding? Just an idea. Though we will be doing it deeply in the next lecture. Suppose the A class has few functions, and one of those functions is HRA. House rent allowance, any function name, okay. Now this C class is inheriting A class and B class also, right? If this inheriting class, if this derived class redefines a method which is already there in the base class, we call it method overriding. That is, if the C class redefines HRA method with the same type and signature, same number of parameters and same data type, then this concept is known as method overriding. Because when the HRA method will be called through the object of C class, it will never execute the HRA method of the base class. It will always execute the method which is redefined, which is overriding in the derived class. So that concept is very essential to understand this diamond problem. Now let us come to this lecture. This is your first program, multiple inheritance, right? Now what I am doing here is a class rect which has one default constructor and a function. There is another class triangle which has a default constructor and a functional TRG area. Now this is a class average which inherits both the classes, rect and triangle. So obviously what will happen that the object of this average class can access the functions and attributes of this rect class, this functions and attributes of this triangle class, and obviously it can access the attributes and functions of its own class. So through the object of average class, you can compute area of rectangle, area of triangle, as well as the average of three values. Here I am using the default values. Okay, now let's see how. This is the object R of average class, right? How many arguments are here? Nothing. So obviously the Python compiler will look for a default constructor in the average class. I hope that you know the concept about default constructor and parameterized constructor. If you haven't seen my earlier lecture which was based on classes and default and parameterized constructor, I am providing you the link in the description box about the whole playlist of the videos. Then it will become very easy for you to understand the concept of this lecture, right? So the compiler will jump to the default constructor of the average class. This is the default constructor. Here we are asking to invoke the default constructor of rect class. So the control will come to the default constructor of the rect class. And here these default values 8 and 5 will be assigned to the length and breadth attributes. And these length and breadth are the instance attributes of the object R. Right? After executing the default constructor of the rect class, control will come over here in the default constructor of the average class. Here you are asking to invoke the default constructor of triangle class. Control will jump to the default constructor of the triangle class. Here these are certain default values. It can be anything, right? So 17 and 13 are assigned to the base and height attribute of the R object, right? After that, the control will jump to the default constructor of the average class here on this line, and these default values will be assigned to the P, Q and R attributes. These values can be anything, right? After assigning the default values to length and breadth attributes, after assigning the default values to base and height attributes, and after assigning the default values to these P, Q and R attributes of the R object, control will come back to the main function. Here you are displaying the line area of rectangle is, and you are invoking the rect area function through the R object. Obviously, the R being the object of average class, which is inheriting the rect and triangle class, so this R object has the right to access the rect area function of the rectangle class. Here the control will jump, and the multiplication of length and breadth, that is 8 into 5, will be computed and returned here. So you get 40 value displayed here. Area of triangle is will be displayed on the screen, and you are invoking the TRG area of the triangle class. Cursor will come over here. Half into base into height, that is half into 17 into 13. Whatever the result is will be returned and displayed over here. Then after, the AVG value method is invoked to compute the average of three values P plus Q plus R divided by 3, and the result will be returned and displayed here. So let us copy this multiple inheritance program and paste it in the spider IDE. I am running it. See, area of rectangle is 40, area of triangle is 110. This 40 has come because of this 8 into 5, 110.5 has come half into 17 into 13, and average of three values because of these values 3. 11 plus 9 plus 5 divided by 3. See, this result of average is very precise to many precision values. We can make it appear to two places of decimals by writing %.2f. This is the format specifier, and here you have to remove this comma and add a percentage here. So after removing the comma and after adding this percentage symbol, the statement is ready to display the result to two places of decimals. Now here we have assigned the default values to these length and breadth attributes, base and height attributes, P, Q and R attributes. Is it the only way to assign default values? No, there is one more way. See here. Again we are calculating the area of rectangle, area of triangle and average of three values through multiple inheritance, but by assigning default values through another way. See, here you are making an object of R class. Here you can see that there is a rect class. There are no default values here. They are being passed from the derived class. Again a triangle class, it has a parameterized constructor. The default values are not there. Okay, they will be passed from the derived class. We'll see how. And here there is an average class which is inheriting the rect class and triangle class. You are making an object R of average class. The moment compiler will look at these three values, it will search for a parameterized constructor in the average class. Here is the parameterized constructor. In the earlier program we used the default constructor, right? So the value 3, 9 and 7 will be assigned to these parameters A, B and C. Now you are not invoking a default constructor, you are invoking the parameterized constructor of the rect class and taking the values which are assigned to those A and B parameters, that is 3 and 9 will be taken. So the parameterized constructor of the rect class is invoked with these values A and B taken along with it. This A and B will be assigned to this X and Y parameters, and from X and Y they will be assigned to the length and breadth attributes of the R object, right? Control will come over here in the parameterized constructor. Again you are invoking the parameterized constructor of the triangle class, taking these two values A and B, that is your 3 and 9. These values can be anything, right? So control will come over here to the parameterized constructor of the triangle class. This values of A and B will be assigned to this X and Y, that is 3 and 9 will be assigned to these X and Y parameters, and from there those values will be assigned to the base and height attribute of the R object which has been created. Okay. After executing of the parameterized constructor of the triangle class, control will come over here, and these values A, B and C, that is 3, 9 and 7 will be used to initialize the attributes P, Q and R. See, let me tell you, this R is the attribute and this R is an object, so it won't collide. Compiler will never get confused. Okay. After that you are invoking the rect area function through the R object. It will return the length into breadth, that is 9 into 3. Here you are invoking the TRG area function which will return the half into base into height, that is half into 3 into 9. And here you are invoking the AVG value function which will find the sum of 3 plus 9 plus 7 divided by 3. So rest of the things are same, but here we learn how to invoke the parameterized constructor with certain default values. I am running it. See. Now we'll do the multiple inheritance, but this time the values will be supplied by the user. Very simple program. See, again rectangle class with a default constructor and one method. Again a triangle class with default constructor and a method. And average class is inheriting the two classes, rect and triangle. We'll start from the main function. You are making an object R of average class. There are no arguments while making an object, so control will look for a default constructor. Control will come over here. Here you are invoking the default constructor of the rect class. Control will come over here. Here the user is asked to enter length and breadth, and whatever the value user will enter will be typecasted and assigned to length and breadth attributes. After executing this default constructor of the rect class, control will come over here in the default constructor of the average class. Here you are invoking the default constructor of the triangle class, so control will come over here. This is the default constructor of the triangle class. User will be asked to enter base and height values, which will be typecasted into integer and will be assigned to the base and height attributes, right? Thereafter, user will be asked to enter three values, and that will be used to initialize the P, Q and R attributes of the R object. After that, it is very simple. We have been doing it again and again. So, let us copy and run it. See, it is asking you to enter length. I'll enter say 4. Enter breadth, I'll enter 7. Whatever the values. Base 3. Height, I can enter anything. I enter 9. It is asking the three values for the average, right? So I'll enter anything. 5, 9, 2. Now see, area of rectangle is 28. How? Multiplication of 4 and 7 is 28. Area of triangle is 13.5. How? Half into 3 into 9. So that comes out to be 13.5. And the average of three values, that is 5 plus 9 plus 2 divided by 3 is 5.333, right? So this is how the multiple inheritance is done, and the values are asked by the user. Let us do one more program on multiple inheritance. There is a class student which deals with the two attributes roll number and name. It has a function to display these roll number and name. There is another class marks which deals with two attributes maths and physics, right? And it has a function disp marks to display those maths and physics. And it has two more functions, physics marks which returns the physics marks only. One more function, maths marks, which returns the maths marks. What are this function for? This will return the physics and maths marks to the derived class so that we can do the total of them. We'll be calculating total of the two subjects also in this derived class. The class which is inheriting both the classes, student and marks, it will be displaying the total of the two subjects also. There's a result class which inherits both the classes, student and marks, right? To understand it, we'll start from the main function. You are making an object student info of result class, which is inheriting both the classes, student and marks. And while making an object, you have 110, bin 2, 70 and 80, 4 arguments. So obviously, the compiler will look for a parameterized constructor with 4 parameters. And this is the parameterized constructor of the result class. This 101 will be assigned to this R parameter. Bin 2 will be assigned to this N parameter. N stands for name. And this 70 and 80 will be assigned to this physics and maths, P and M parameters. Here obviously you are invoking the parameterized constructor of student class, and you are taking the values in the R and N parameters. So this R and N having the values 101 and bin 2 will be carried to this parameterized constructor of the student class. The values 101 and bin 2 assigned to this X and Y parameters will be assigned to the role and name attributes of the object. Cursor will come over here. Here in the parameterized constructor of the result class, you are invoking the parameterized constructor of the marks class also. And you are carrying this P and M parameters, that is these values. 70 and 80 will be carried. Those values in the P and M parameters will be assigned to this U and V parameter. And this 70 and 80 through U and V parameter will be assigned to those physics and maths attributes of the object student info, right? After that, the cursor will come over here. I have commented it out. See, here the result class has two attributes, total and percentage. In this total attribute, I want the sum of physics and maths marks of this marks class, right? Because the result is inheriting the student and marks classes, so its method has the right to access its attribute using the keyword self, right? So the physics and maths values assigned to these two parameters will be accessed and assigned to this total attribute of the result class. There's one more way. You are invoking the physics marks method. This is a physics marks method which returns the value in the physics attribute, and you are invoking the maths marks method, this one, which returns the value in the maths attribute. So the values in the physics and maths attributes can be accessed through these two functions and can be added to define the value of this total attribute. Here you are computing the value of the percentage attribute which is nothing but the total divided by 2. It's a percentage, right? After that, the cursor will come over here. You're invoking the dispResult function through the student info object. Cursor will come to the dispResult function. You are invoking, see here, this is a method to invoke the base class method in the derived class. Okay. So here you are invoking the dispStudent method or function in the derived class. So here you are invoking the dispStudent function of the student class. So control will come over here. It will display the roll number and name which are assigned to the role and name attribute of the object. After displaying the roll number or name, cursor will come over here. You are invoking the dispMarks method of the marks class from the derived class, right? So this is what we wanted to learn. So control will come here. This method will display the physics and maths values which are assigned to those physics and maths attributes. After that, you are displaying the total, right? So total is displayed through the total attribute and percentage is displayed through the percentage attribute. Let us copy this program. See, 101 bin 2 and 2 separate marks, and this is total and this is the percentage. If you remove the comment from here and you comment out this line, see the total will be same. You can access the physics and maths marks using the self keyword also in the derived class of the base class. That is, the base class attributes can be accessed by using the self keyword. I repeat, the multiple inheritance is not yet over. You have to understand method overwriting and the diamond problem, which is very popularly asked in the interviews and exams. So don't forget to watch the lecture 19 for method overriding and lecture 20 to understand how the diamond problem is solved in Python. If you followed this lecture, please subscribe to my channel, write comments, share the video with your friends. Thanks for watching the video. Have a nice day.